Welcome back to another deep dive here on GCSE Science Simplified.
Great to be here.
Ever wondered, how your phone talks to a satellite way up there?
Uh-huh.
Or how doctors can actually see inside your
He's
bones?
out cutting you open, yeah.
Exactly. Well, today, we're diving into the invisible forces behind all that.
Yeah.
Electromagnetic waves and the electromagnetic spectrum. Our mission really is to break down this key physics topic for you, make it clear, maybe even a bit exciting. We're drawing on reliable info, like from BBC Bitesize.
Good source.
And these EM waves, they are literally everywhere. I mean, the radio you might listen to, the light letting you see right now, even X-rays at the hospital.
Absolutely. And at their core, electromagnetic waves are a type of transverse wave.
Okay, transverse wave, what does that mean exactly?
It means they're vibrations or oscillations, that regular back and forth movement. They're actually changes in electrical and magnetic fields.
Right.
And crucially, these fields oscillate at right angles, like perpendicular to the direction the wave itself is traveling.
Okay, got it.
And what's really cool is that all EM waves, they share some key properties. They all transfer energy as radiation.
Energy transfer, okay.
They can travel through a total vacuum, like outer space, no medium needed.
Unlike sound waves, for instance.
Exactly. And they all zip along at the same incredible speed through a vacuum or even just through air. It's about 300 million meters per second.
Wow, 300 million. That's mind-bogglingly fast. So these waves, they're not just one single thing then?
Not at all. They form a continuous spectrum. Think of it like a giant, mostly invisible rainbow of energy.
A spectrum, okay.
Yeah, it ranges from waves with really long wavelengths, which means low frequency and low energy, all the way down to waves with incredibly short wavelengths.
Which would be high frequency, high energy, right?
Precisely. And we usually break the spectrum down into 7 main groups, just for convenience, really, in order of increasing frequency and energy.
Okay, lay them on us. Is there an easy way to remember the order?
There is. The classic mnemonic. Roman men invented very unusual X-ray guns.
Roman men invented very unusual X-ray guns.
Okay, so R is?
Radio waves. Then M for microwaves, I for infrared, V for visible light.
That we actually see.
The tiny bit we see, yeah. Then U for ultraviolet, X for X-rays, and G for gamma rays.
Radio, microwaves, infrared, visible, UV, X-rays, gamma rays. Got it.
And it's amazing, isn't it? That whole world of color we perceive.
Yeah.
Visible light. It's such a minuscule slice of the entire spectrum.
Really puts it in perspective.
It really does. Within that visible slice, red light has the lowest frequency that we can see, and violet has the highest.
Okay, and you mentioned frequency is linked to energy and danger.
That's absolutely crucial. Higher frequency equals more energy, and generally more energy means potentially more dangerous.
So gamma rays are the most dangerous.
By far. And radio waves down at the other end are the least harmful.
What sort of damage are we talking about with the higher energy ones? Like UV, X-rays, gamma rays, you hear about ionizing radiation. Yeah, that's the key term, ionizing radiation. Those waves, UV, X-rays, and gamma rays, carry enough energy to actually knock electrons clean off atoms or molecules.
Right, like a tiny collision.
Exactly. It creates ions, charged particles, and that process directly damages our cells, our DNA even.
Yikes. So what are the specific risks?
Well, for overexposure, microwaves can cause internal heating of body cells. Infrared, think intense heat, can cause skin burns.
Okay.
UV, ultraviolet, that can lead to eye damage, damage to surface cells like sunburn, and, increases the risk of skin cancer over time.
Right. Always wear sunscreen.
Definitely. And then X-rays and gamma rays, the really high energy ones, cause more severe damage, cell damage, mutations, and a significantly higher risk of cancer. That's why their use is carefully controlled.
Makes sense. So despite the risks at the high end, this whole spectrum, it must have loads of uses, right?
Oh, absolutely indispensable uses. The diversity is incredible. If we start back at the long wavelength end, radio wave.
Broadcasting, TV, radio signals.
Yep. TV, radio, communications, satellite signals. Basically, we make electrons oscillate, wiggle in electrical circuits. That creates the waves. Then a receiver picks them up, reverses the process, and decodes the information.
Clever. And microwaves.
Yeah.
Beyond the kitchen oven.
Well, cooking's a big one, heating the water molecules in food very efficiently, but also vital for communications like mobile phones sometimes and satellite transmissions.
Okay, moving up. Infrared, IR.
Think heat, electrical heaters, cookers, but also your TV remote control uses infrared pulses and thermal imaging cameras. They detect the infrared radiation objects give off, letting us see people or animals in the dark.
Very cool. And then visible light. Our little slice.
Well, obviously vision, photography, lighting, but also fiber optic communications, sending data as pulses of light down thin glass fibers. That's how a lot of the internet works.
Amazing. Okay, higher energy now. Ultraviolet, UV.
UV has some neat uses. Security marking that only shows up under UV light, fluorescent lamps rely on it, checking banknotes for authenticity, even disinfecting water as it kills bacteria.
Useful stuff. And X-rays. We mentioned hospitals.
Medical imaging is the big one. Seeing bones, sometimes soft tissues. Also, airport security scanners, looking inside luggage, and even in industry to inspect materials or welds.
Right. And finally, gamma rays. The most energetic.
Despite being dangerous, they have critical applications when used carefully. Sterilizing medical equipment, killing all microbes, sterilizing food sometimes too, and in medicine, both for detecting cancer and, paradoxically, for treating it in radiotherapy.
Wow, it's just incredible, really. The same fundamental thing, these electromagnetic waves are doing everything from broadcasting music to cooking food to diagnosing illnesses. They're just woven into everything we do.
Completely, often unseen, but constantly shaping our world and our technology.
So much going on invisibly around us.
And here's a thought to leave you with. We know all objects constantly absorb and emit infrared radiation, right? That's directly tied to their temperature.
Yeah, thermal cameras show that.
Exactly. So how might really understanding that constant energy exchange, how might that change how we think about heat loss in our homes, maybe? Or even energy transfer across the vastness of the universe?
That's interesting. Thinking about that constant flow of invisible energy, definitely something to ponder.
Keep exploring those invisible forces. There's always more to learn.